Reinforced concrete is a composite material in which concrete's relatively low tensile strength and ductility are counteracted by the inclusion of reinforcement having higher tensile strength or ductility. The reinforcement is usually, though not necessarily, steel reinforcing bars and is usually embedded passively in the concrete before the concrete sets. Concrete is a mixture of coarse and fine aggregates with a paste of binder material and water. When cement is mixed with water, it hydrates to form microscopic opaque crystal lattices, encapsulating and locking the aggregate into a rigid structure. Typical concrete mixes have high resistance to compressive stresses. However, any appreciable tension will break the microscopic rigid lattice, resulting in cracking and separation of the concrete. If a material with high strength in tension, such as steel, is placed in concrete, then the composite material, reinforced concrete, resists not only compression but also bending and other direct tensile actions. A reinforced concrete section where the concrete resists the compression and steel resists the tension can be made into almost any shape and size for the construction industry. Rebar, short for reinforcing bar, collectively known as reinforcing steel or reinforcement steel, is a steel bar or mesh of steel wires used as a tension device in reinforced concrete structures to strengthen and hold the concrete in tension. Rebar surface is often patterned to form a better bond with the concrete. Therefore, when the cement paste with the concrete hardens, this conforms to the surface details of the steel, permitting any stress to be transmitted efficiently between the different materials. The coefficient of thermal expansion of concrete is similar to that of steel, eliminating large internal stresses due to differences in thermal expansion or contraction. Primary reinforcement refers to the steel, which is employed to guarantee the resistance needed by the structure as a whole to support the design loads. Struts form outer part of rebar cage. Struts are usually rectangular and are placed at regular intervals along a column or beam to prevent shear failure. Although rebar has ribs that bind it mechanically to the concrete, it can still be pulled out of the concrete under high stress, an occurrence that often accompanies a larger scale collapse of the structure. To prevent such a failure, rebar is either deeply embedded into adjacent structural members with these plastic pieces, or bent and hooked at the end to lock it around the concrete and other rebar. This first approach increases the friction locking the bar into place, while the second makes use of the high compressive strength of concrete. Metric bar designations represent nominal bar diameter in millimeters. Any material with sufficient tensile strength could potentially be used to reinforce concrete. Glass and basalt fibers are also common. There is considerable overlap between the subjects of non-steel reinforcement and fiber reinforcement of concrete. The introduction of non-steel reinforcement of concrete is relatively recent. It takes two major forms: non-metallic rebar rods and non-steel fibers incorporated into the cement matrix. For example, there is increasing interest in glass fiber reinforcement concrete and in various applications of polymer fibers incorporated into concrete. Although currently there is not much suggestion that such materials will in general replace metal rebar, some of them have major advantages in specific applications, and there also are new applications in which metal rebar simply is not an option. However, the design and application of non-steel reinforcing is fraught with challenges. For one thing, concrete is a highly alkaline environment, in which many materials, including most kinds of glass, have a poor surface life. Also, the behavior of such reinforcing materials differs from the behavior of metals, for instance in terms of shear strength and creep and elasticity. For a strong, ductile and durable construction, the reinforcement needs to have the following properties at least: high relative strength, higher toleration of tensile stress, good bond with concrete irrespective of pH, moisture and similar factors, thermal compatibility, not causing unacceptable stresses in response to changing temperatures, durability in concrete environment irrespective of corrosion or sustained steel, for example.